I'm not sure how will you do the team project. I'm I'm wondering whether you are going to use Orange or you are going to use Python. But let me just give you a very brief example how we can apply the algorithm in Python. If you already know this stuff, yeah, I think it will be good. But if you are the new comers for Python, I hope that this will give you some insight how to use Python for the machine learning. This is a very simple code that I prepare for you. In this case, I'm going to use the regression. Okay. So last time I think I already explained this one. The target is numerical data. So we have three kind of algorithms for the comparison. Of course, you can have more algorithms, but let me just show you three algorithms here. And we are going to have the housing data set. So what is housing data set? I think last time I mentioned to you, we have the house price. So we have the house price with the information from the house. For example, what is the lot size? How many number of bedrooms? How many bathrooms? How many stories? So we know all the properties of the house, like whether the house is located in the driveway, it is a recommended room or not, whether they have the full base or they have the gas, and whether they have the aircon, whether they have the garage, and whether it is a preference area or not. So with those information, I know that the house price is this one. So let's say I have another information. Maybe I know about the lot size, I know the bedrooms, I know the bathrooms. So how do we know about the price? Can we predict the price? So that will be the goal. So when you do your tip project, please mention what is the goal. And you need to specify what is the column. Because if you just mention the goal without mentioning the column, then it's not clear. So you need to make it clear what is the column for your prediction. In this case, the housing data set, we have the column price. So we can just import some functions. The matplotlib, numpy. I'm going to use the simple sklearn, and I'm going to use pandas. And I'm going to read. This is the CSV file, so I'm going to read the CSV file with the read CSV. And then I will determine what is the X and what is the Y. So Y is the target. And then X is the attributes or the explanatory variables. Okay. So the variables that can determine the target. Let's say I use only one, which is the lot size. So I just want to know whether the lot size will determine the price or not. So if I know the lot size, this size, can I predict the price? So that will be the question. Then, yeah, we just use the tree shape. This is to change this data frame into a format for the training in the algorithm. So we change the X, we change the Y, and then we split the data. So here I split data. I'm going to use minus 250 from 0 until minus 250. The X test minus 250 until the end. So if you know this one, it means I will do the last minus 250 data. So it means I would like to use from the 0 until the last 250 data. And the testing, it will be from the minus 250 until the end. Yeah. Basically, it is up to you. If you learn from the lectures, you know that we can have like 80-20, or in the hold out method, we have 60 training and then 20 validation and then 20 hold out. Yeah. So you can also define like this one. But most of the problems that has been shared in the GitHub or in the Kaggle, usually they have only two, train and test. And you can define with number like this one, or you can set with the percentage. So we will see how to define with the percentage later. So when you split the X, of course, you need to split also the Y. Y train and Y test with the same number. So I'm going to plot. I'm going to plot the testing data, the test data, and then I would like to plot the size, which is from the lot size, and then I would like to plot the price. And in this case, I'm going to use the linear regression. So there's one algorithm, linear regression. I don't explain the details of the linear regression. I guess you already got those stuff in the statistics. So I'm just using this algorithm. So this algorithm is called, and then I put it into one variable. So I'm making a new variable, and this variable will be used to train the X train and the Y train. So we are creating the model. So we call this is the model creation. If you still remember, when we do the classification, yeah, we have the model creation. And then predict. So this predict means we are going to use the prediction function. It is to model usage or model evaluation. Here I'm going to plot the X test, and then I'm going to plot the result of the prediction. The result of the prediction will be the Y, or this will be the prediction is the price. Okay. So the X test is the size. Then I can see the size is the X, and then given the X, I can predict the price. So this is the result of the prediction from 250 data. Yeah, actually you can have the score. Okay, so I give you the way to show the score. Let's say I'm going to use another algorithm. Let me just run this. Okay, so let me just have another algorithm. This algorithm is Ritz algorithm. The Ritz algorithm, the same, we just call the Ritz and then we fit. So the basic idea is we need to create the model and then we need to evaluate the model. Model creation and model evaluation. And then we have the, in the regression, we can know there are some ways for the performance measures. I'm using R square. So in the most common way, we can use the RMSE, MSE, MAE. Okay. I think you already know this one. Root mean square error. So we learn also in our class mean square error. And then we have the mean absolute error. Closer to zero is the best. Closer to zero is the best. Closer to zero is the best. But we can have also the R square. Maybe you usually said R cubic. So the R square near 1 is the best. So if you look at this R square, the R square is very low. And this is also minus. Then this model is not that good. You need to find another model. I'm going to use another algorithm, which is Lazo. So again, basically you just use fit. This is the model creation. And we are going to evaluate the model. And again, you will see, let me run this. And then let me run this one. So basically you can see that those two results are similar. They are the same. So the R square is not that good. And you can see from this, the error is very huge because the model is not that good. It means you need to find some other algorithms. So if you want to use the Python, I just give you this basic one. Of course, you need to find what is the best algorithm, and then I can let you know when you do the consultation with me. When you meet me, then I will let you know if you want to use Python more. The second example that I want to show is the basic classification. We know the classification means the target is categorical data. So in this case, I'm just using three kind of algorithms: random forest, decision tree, and KNN. And let me just use the iris dataset. I think you still remember the iris dataset, the flower dataset. So again, I'm using some libraries in the Python, like the pandas, and then I'm going to let you know how to split between the train and the test. And I'm going to use some algorithms like the random forest. And then we are going to see some performance measures for the classification. For example, the confusion matrix, the accuracy score. I'm using this link to get the data. So the data has been shared in this link. If you want to see, think this one. So you can, if you go to this link, then you will directly download the data. So let me just open with the notepad. So the iris.data, you can open it with the notepad. And yeah, the data is something like this one. 5,1, 3,5, 1,4, 0,2, and then it is iris setosa. If you still remember, we have 4 attributes. What are they? Petal, we have petal length, petal width, we have sepal length and sepal width. Okay. So we have 4 attributes: petal length, petal width, sepal length, sepal width, and we know what is the flower name. It is the iris setosa. So yeah, you can see we have also another flower which is iris versicolor, and we have another flower which is iris trigenital. So by using this data, we are going to use the comma as the separator, and then because there is no header, so we specify the header equals to none. We do not put the header at this moment. And we are going to use all the data from all the rows and from the all columns. And we are going to put it into the data. At the first time, let's check the null values, whether there are some null or not. So we check with this one, is null.sum. If there is null, then you need to do something. Maybe you need to change or you need to modify, you need to delete. You can add some values, or you can use min, you can use median, and etc. I'm going to make x and y. So this is the common way. X means the variable that you can use to do the prediction, and the y is the target. So as we see from the data, we are going to use the x for all data. But we have the column -1. What does it mean? In Python, we have the rule. -1, it means the last column. Okay. So if we know that this is the column number, maybe we don't know number 1, number 2, number 3, number 4, number 5. Okay. But in Python, you will define it based on the array 0 base. So this is the index 0, this is the index 1, it is index 2, it is index 4 and 3, and this is the index 4. Or if you change the order, then it is -1, it is -2, it is -3, it is -4, and this is the -5. So this is how we see the data in Python. Because this will be the target, or this will be the y, then I can know that this is the column index 4. Or I can say that I'm going to use for all the columns until -1. Then it means I will use 1, 2, 3, 4, except -1. So the X will be used for all data without -1, and the Y I'm going to use only the column index 4. Encoding. Encoding means we want to encode or we want to change the label, because in Python you cannot have the you know that this is categorical data. Iris versicolor, iris setosa. So you cannot use this classification if the data is categorical. Then we will do the encode in order to change this iris setosa into number. Maybe this one is 1. And then it will check again another label. This is iris versicolor. So we will change it into another number. Maybe this is 2. And then it will check whether there is another categorical. Okay, we have iris virginica. So the label encoder will change to the number. This is 3. So that's the function of this label encoder. After we have the number, we can split the X into X train and X test, and we are going to split also the Y into Y train and Y test. In this case, we use the train test split. The test size equals to 0.3. It means we are using 30% for test, and the remaining is 70%. It is for the training. So this is the meaning by 0.3. And then the random step, this is just to make the result the same. In your computer and in my computer, we will keep the same result. Because when we do the random, sometimes computer, each computer, they will have their own random function in order to make the same result. So we make the random state. At first, I'm just using one algorithm, which is random forest classifier. I call the algorithm. Okay, so whenever you do with the Python, first you need to call the algorithm. And then after you call the algorithm, you need to create the model or model creation. And then you need to evaluate the model. Okay, so that's the basic step. We create the model and then we evaluate the model. Once you have the prediction, so we have the classifier, which is the model, and we have the predicted, which is the result of the prediction, then you can do the confusion matrix. The confusion matrix is based on the actual data versus the prediction result. And you can have the accuracy between, again, the actual data and the prediction result. And we can make the classification report. This is the actual data, and then this is the prediction result. So if I just run this, sum of null values. It means I want to check whether the data has null or not. Okay, 0, 0, 0, 0, 0. So there is no null. And then after we do with the random forest classifier, we can get this confusion matrix. So the confusion matrix, I guess you already know. This is the actual and this is the predicted or the prediction result. 16, it means it is in the class 1 and then it is predicted in the class 1. It is in the class number 2, it is predicted in the class number 2. It is actually in the class number 3 and then it is predicted in the class number 3. So you can see that there is one missing or this is misclassified. So the accuracy score is 0.97 because we have only one misclassified. And you can check the precision recall for every of the class. And you can see the F1 score and you can see the accuracy, the overall accuracy for all the data. Okay. I'm going to use another classifier, which is the decision tree. Again, I can create the model. And then I will do the model evaluation. And then I can create a confusion matrix. I can check the accuracy score and then I can make the report. With the decision tree classifier, I want to check the result. And okay, it is the same with the random forest, 0.97 something. So we can round up the numbers into 0.98 as the accuracy. And let's try to use another classifier, which is the KNN or K neighbors classifier. We call the K neighbors. Usually we call it K nearest neighbor. So that's why I put the KNN. We can use another way to print the accuracy. So here we can have the model creation. And then we want to evaluate the model. Just using the score function, actually we can check the accuracy. If you still remember, underfitting and overfitting. Overfitting means if the accuracy, the error of training is high and the error of testing is also high. So the model is not good because the error is high and the testing also high. We want to just find the right model. How about overfitting? The error training is low or the accuracy is high and the error of testing is quite low, I guess you can say this one, and accuracy also high. So I'm showing this one. You can see if I'm using the X train and Y train, and if I look at the score, the result is 0.97. But here, when I use the testing set, the result is 0.98. then yeah, you can figure out whether it is underbidding or overbidding, because we know the result from the training and we know the result from the testing. I think I need to use the prediction result, not this one. We need to do the prediction with the X test, and then the result from the predicted should be here. Okay. Yeah. I'm sorry, I missed this one. When we do the model evaluation, we need to predict. Okay. Fit and predict. So that's two functions that you need to use, fit and predict. And after you have the prediction result, you want to see on the score or the accuracy of the prediction. Okay, the accuracy of prediction is very high, which is 1. Then, yeah, this is something strange actually, but it can happen. Okay, I will not explain more because I think you just need the basic one for this Python. You can choose whether you want to use Orange or you want to use Python for your team project. Any questions? So I think it's better to start to find a time between your team and me. So you can set the available time. What is the best time for you to meet me? Maybe next week and or next week. Okay. So maybe on the break time, I will let you know what is my available schedule, and you can select based on that available schedule. Okay. And on next Tuesday, as I mentioned to you, please try to figure out the exploratory data analysis. I have already opened this team project section. So you need to show the exploratory data analysis. If you are using Orange, then please submit the Orange file. If you use Python, then please submit the Python file. Okay. Okay, then let's continue with the next section. Okay, I'm going to explain about clustering. So in this chapter, we are going to learn about the cluster analysis and some of the methods like partitioning methods and hierarchical methods. So what is cluster analysis? Cluster, or sometimes people also mention as group. It is a collection of data objects. We can think the cluster in two different ways. The first is based on the similarity. You still remember similar? The similarity. If you are thinking from the similar perspective, then we are going to check the similarity or the related objects to one another within the same group. So if we have this data, okay, then I'm going to check whether they are similar or not. What is the similarity? We can check based on the distance. We can check based on the distance. So in this case, all the objects are in the similar distance. All the objects are in the similar distance. In different perspective, we can say the dissimilar. Dissimilarity. The dissimilarity means the distance. It is the dissimilar or unrelated to the objects in other groups. So if you look at the blue and the red color, there are some distance. The green color and the blue color, they have some distance. So we want to make the similar objects into one group, and we want to make the dissimilar objects into different groups. That's the basic idea of cluster. In a cluster analysis, sometimes you will see the word clustering, or sometimes you can see data segmentation. It means finding similarities between data according to the characteristic found in the data and grouping similar data objects into clusters. If you still remember the unsupervised learning, so let me just give you the image what we learned before. If we have the data set and if we do not know the class, we do not know the target, we do not know the label, then we call this is unsupervised learning. No predefined classes. So it means we are just learning by observation. We can see only the data, but we do not know what is the meaning of the data. Then this is the observation. It is different with the learning by examples. So we call the supervised learning is learning by examples. The typical application is a standalone tool to get insight into data distribution. So if you look at the binning, for example, you still remember binning? When we do binning, we have only the very simple binning like the equal width, equal frequency. So that's also a tool to see the data distribution. The clustering, we can use also as a tool to get insight about the data distribution. Sometimes we can use this as the pre-processing step for other algorithms. So if you still remember when I explained to you about the self-supervised learning. Self-supervised learning, it means I will do the clustering first, and then after I have the clustering result, I will do the classification. Okay, so the clustering is the pre-processing before classification. Okay, let's see. I have this kind of data. So currently, clustering will solve a problem as an unsupervised learning. We can store features in the database without any labels. Let's say I have phone ID. So maybe this is a kind of jumbo phone, second-hand phone. So I know the phone number one, the battery. The battery means how many hours the battery can last. okay, I know that this phone ID1, the battery can last for 12 hours. And the camera is 8 megapixel. Camera pixel. So phone number 2. Oh, the battery can last for 26 hours. And the camera is 16 megapixel. So I want to know, can I make a different class of the camera? Maybe I can determine the good quality second-hand phone and the low quality second-hand phone. How can I make this one? So the simple way to make this distinction is to see the distance. So by plotting like this one, I can plot based on the battery and based on the camera pixel. Then I can see that, okay, this is the phone number 1, this is the phone number 8, this is the phone number 6, this is the phone number 4, this is the phone number 3, and then this is the phone number 2, this is the phone number 9, this is the phone number 7, this is the phone number 10, and this is the phone number 5. So you can see that it seems they are in the same group. And it seems they are in the same group. So, yeah, because on this distance, I can assume that this data is in the cluster 1 and this data is in the cluster 2. This is just based on the distance measurement. And then I can create the label. So what does it mean by this label? Yeah, it depends on your analysis. Maybe I can say that the cluster 1 is the low class phone. And the cluster 2 is the high class phone. Or maybe I can say the cluster 1, yeah, we can sell the phone with the cheaper price. The cluster 2, we can sell the phone with the high price. And etc. But usually when we do the clustering, we just make the word clusters. So this phone, it is in the cluster 1. This phone is in the cluster 2, and so on. So using the stock features in the database, we can measure the distance and we can create the clusters. So the clustering problem can now be expressed as given a data in the database. So this is the database. So create the possible class label according to the similarity or the distances of the features. So there are many applications you can do with this clustering. If you learn the iris dataset that I explained before, yeah, it is in the biology. So you can check the similarity. I think if you learn in the biology, yeah, you know the species, what is the species and what is the genus, family, order, class, phylum, and then the highest one is the kingdom. Okay. We can also do with the information retrieval, okay, to cluster the documents. We can have some kind of observation for the land use. So usually in the satellite, yeah, we can see from the satellite whether it is forest or whether it is housing or whether it is road based on the color. So we can use clustering for marketing. We can use it to segment the customers. Who is the high level customers? Who is the low level customers? and so on. City planning. And we can group the houses according to their house type or the value or the geographical location. So if you know the location, you can just divide with gu, dong, sujigu, choingu, dihonggu. They determine the border. But with the clustering, we can have another result. The earthquake, we can use the data to find the effect of the earthquake. So, for example, we observe the earthquake epicenter, and then we can check what is the surrounding area that can have the effect of the earthquakes. The climate. So we can understand the earth climate and some patterns based on the atmosphere and the ocean. And some other things like the economic science. Let me stop here. Let's have a break.